8.3, number 53, 4 parts. Part A says show that this diverges. So no points of discontinuity, just an infinite boundary right up there. But it looks like a u substitution, u is x squared plus 1. So dx equals du over 2x. So it's the integral of 2x over u times du over 2x from 0 to b as b approaches infinity. So it's the integral of 1 over u du. So natural log absolute value of u. So natural log of x squared plus 1. We don't need parentheses because that's always going to be positive. We're going from 0 to b as b goes to infinity. And if I drop in your b or infinity, we get natural log of infinity, which is infinity, so it diverges. Okay, so from 0 to infinity diverges. Part B. Well, then the integral from negative infinity to infinity must diverge because, well, if like the right half of it from 0 to infinity diverges, then the entire negative infinity to infinity must diverge because the entire both halves of the integral has to converge. So this one would have to converge, and then this one would have to converge. And we already know that from 0 to infinity diverges, so then this integral must diverge. They both have to produce a finite number in order for this to converge. Now part C says show from negative b to b that it's 0. So if we graphed 2x over x squared plus 1 It's beautiful. Try it again. And graph. Okay, so it does appear to be an odd function because if you look at it and then flip it upside down, it's the same. We can prove that it's an odd function. Odd functions f of negative x equals negative f of x. So maybe I'll try that. So f of negative x equals 2 times negative x over negative x squared plus 1 gives you negative 2x over x squared plus 1. And negative f of x is just negative the whole thing, and that negative can either go on top and bottom or out front. I'll move it to the top and then it becomes what we have before. So f of negative x and negative f of x are the same. That's the definition of an odd function. So if we're going to integrate from negative infinity to infinity any odd function, you can see that we're going to have just as much negative area as we have positive area. So negative, positive, the same amount, you're going to end up with 0. Okay, so that's just a characteristic of an odd function from negative b to b. So if it was from negative 1 to 1, it works. From negative 2 to 2. So as long as these are the same, the b's and negative b's, then you'll always get 0 for an answer. So you get 0 because the odd characteristics of these functions supersedes the value or the divergent integral. So yeah, it diverges this one, but you're still going to get 0 because based on the characteristics of the graph. So how can the integral diverge and still produce 0? Well, in order for the integral from negative infinity to converge, you'd have to have finite answers, finite areas on both sides. Well, this one has infinite areas on both sides, but the infinities end up, so if we have negative infinity area to the left and then positive infinity area to the right, those end up canceling each other off in this case based on the characteristics of the odd functions. So it diverges, but you can still get 0.